I think so much of the barrier is the tooling. I think a lot of people are focusing on what's the capability of the AI itself. And the reality is that we have a lot of pick and shovel work to do. And that's the case every time we have some new hype cycle and some new cool technology. Yes, there's a lot of promise in this tech. Now let's go solve the tooling and the picks and the shovels to actually make it applicable at scale for most institutions.
Join me in welcoming Phill Rosen. Phill is the CTO at MoneyLion and a serial entrepreneur in the digital finance space. Among other ventures, he founded Even Financial, which was acquired by MoneyLion and has led the recent sale of MoneyLion to Gen Digital. Phill, welcome to the Hybrid Minds podcast. Thank you for doing this.
Thanks so much for having me.
Phill, let's start with, I think, the most important question right now. So where do you think are we heading with AI in terms of intelligence, AGI, and all these, important topics?
It is very cool how many use cases that we've been able to apply AI to that have delivered really tremendous consumer value so quickly. It's interesting in the history of sort of like tech, we often see these waves of hype on new things. Crypto is a great example. And a lot of the time, there's this very, very big gap between the hype cycle and the application cycle where you see value actually delivered. And in the case of AI, it's obvious and immediate that there's been tremendous value delivered. Of course, there is still, in my opinion, a big gap between a lot of the claims and the hype and what we should actually rationally expect to see in the next year. For example, one of the things that always strikes me is you see people like the CEO of Anthropic who might say, I expect 90% of all code to be written by AI within 1 year. And that, of course, to me seems a bit far-fetched and ridiculous just because, a number of companies who are ready to apply AI to large legacy existing code bases and actually make it work within the next year is pretty small. Right. It's going to be really the absolute biggest of the tech companies who can afford to invest in the systems necessary to make that happen. The rest of us will be getting nice efficiency gains. We're going to make our senior engineers much more valuable. We may see that we become more selective about how we staff junior engineers because in many ways, AI is a great alternative to a junior engineer, but we still need software engineers, and most of that software will be written by people, even if it's AI assisted. And then when it comes to sort of the product layer, that's where I think it's most exciting. I think that it's really hard for a lot of companies to go from seeing all the opportunities of things they can apply AI to and actually turn it into a product that delivers value at scale, right? That is a very complex thing to do. And it's even more complex in regulated industries like financial services where I sit. And so it's been really exciting to see that we were actually able to do that in a number of cases in MoneyLion, actually build AI into the product, not just a chat bot or some customer service replacement, but to actually take all of this consumer data we have, all of this data that consumers have trusted us with, and enable the consumer to get better advice and value from that data through the integration of AI into our product suite. So that's really been great. I think it's still very much the early innings, but it's live and delivering value and results both for individuals and the company. So it's really exciting.
So you touched on so many topics. I want to dig deeper. Let's maybe start with Dario saying 90% of coding will be done by AI. So my question to you is this: do you think that I'm sure, or you probably have heard that I think about 2 weeks ago, AI did a competition in programming and turned out to be, I don't know, number 96 from thousands of top engineers already, right? So it can certainly produce code at a very, very high level, right?
Yeah.
So do you think that the reason why it will not do 100% of coding is because engineers will not accept it, or because it is not ready to do it?
It's more a matter of organizations being AI ready, right? And having their code bases be AI ready. If I think about like the amount of software that has been built to make MoneyLion as a company operate. We have tons of services, we have tons of databases, we have all sorts of user experiences in different places. The documentation is great in some places, weak in other places, right? Like, what does it take to actually go and build new features and software, right? Like, simply telling some AI via prompt, go build me this feature, put it in there and get it to production is not possible because it's almost impossible to give it the full context of all of the relevant code, all of the architecture and hidden problems underneath that have to be solved for, all of the business exceptions that have gone into making the thing work, all of the different places that it has to be integrated in order to deliver awareness to the business stakeholders. It's not that AI can't write the code. It's that, like, I think in order to actually have AI truly write a code and release a feature requires having your code base being built in a certain way and available to the AI in a certain way, having an AI system be fully context aware so it can understand all of that, and then have it hooked into a number of other systems that are necessary to actually put that code into production in a way that is trusted, secure, auditable, monitorable, etc. That is a matter of just like it's your code base and your organization and your infrastructure isn't AI ready and still needs people. Now, that doesn't mean AI can't necessarily be involved in every step of code production, right? If you tell me that 90% of code written will be AI assisted in some way, right? That I buy, right? That's obviously possible. That's obviously something that's very easily achievable. We can have 100% of our engineers writing in Copilot. They can have some level of AI assistance involved there, and that might make them more efficient. But to take the engineer out of the equation is not something most organizations can do yet. And I think there's obviously the biggest orgs can solve for that, right? Facebook can put the market cap of a large company behind solving that problem for their code base. Most companies can't do that. I think that, the way I see it is that it is a way to make engineers much more efficient, right? And what they do, right? We can get large efficiency gains from it. I think in many cases, it can replace the need for more junior headcount. I think in my mind, a lot of the time, I basically can sort of see an LLM almost as a replacement for a junior engineer. What is a junior engineer? They take a description of what they want from a senior engineer. That's basically a prompt. Go give me this. They give it back to the senior engineer. The senior engineer reviews it, maybe merges it, maybe puts it into production, right? We can maybe offload some of that, but it's still going to be humans involved and it's still going to be AI assisted. And so I think some of the statements are a little bit over the top.
Got it. And what do you think about these? There's this theory of modularity, right? So our brain comes basically from our brain, has different, areas that are specialized in different tasks. And if you look at the last 6 months or a year in AI development, a lot has been into this direction, right? So you have this agentic systems where they talk to each other, and now you have very nice protocols like MCP and A2A and so on. And what I'm trying to lead to is this. Yes, you might have a super large, code base, and you have databases, SQL, and maybe a graph database, and this and that. But theoretically, you could look at this as I have an agent who is specialized in the SQL database, and I have an agent who is specialized in the graph database. And they talk to each other and achieve something. Sure. Because in real life, it would also almost be like that, right?
Sure. I mean, you can do that. And I think, actually, I'm involved in some companies that are doing something similar to that. I'm an investor and work with a company called Simply Put. And what Simply Put has done is basically built a analytics stack that can work on any database. And you can basically ask it for analysis and graphs of any data set, right, via simple language. And what it has done is introspected the database. It has actually figured out how to understand the database. It gives an opportunity for analysts to provide context to the LLM of how to interpret certain aspects of it. And then it has agents that can query multiple databases and bring the data back together to give you an analytics answer. There's no reason you couldn't have it go and do something via an agent as the next step to it. Makes a lot of sense. There's a lot of places where I think for simply performance reasons, that isn't really viable, right? Like a lot of real-time use cases probably can't actually do that given the performance characteristics of most LLMs today, right? Like there's a lot of things that we're processing that I expect 10 millisecond response times on, right? and those probably aren't going to be work for most models. Where we've seen interesting modularity is in our approach to, let's say, our search and recommendation engine that's AI powered, right? So we have data, consumers have given us data on a large number of different aspects of their life. Maybe their spending, maybe they have credit, maybe their investments, maybe what they've been reading in our system. For all sorts of reasons, we wouldn't pipe that information directly into a model, right? There's a number of reasons we want to do it. First of all, it's not good for the consumer. Second of all, it's not a very efficient way to use the model. Third, I don't necessarily want to give up the IP. So rather what we have is a system where the AI is responsible for figuring out what other systems should be queried and writing queries on those systems. So if it says like, how do I do X, Y, and Z? The result of that is going to basically be AI saying, you're going to call these 5 different systems with these 5 different questions, and you're going to stitch the answer together like this. It never sees the underlying data, right, at any time. It never knows anything about the consumer specifically. Its job is to figure out how to answer the question by traditional systems and talking to those different systems.
Yeah, that's wonderful. That's a very good way of doing it, right? So basically, you're combining these stochastic properties of an LLM with symbolic querying language, SQL or whatever.
And it'll generate SQL in some cases. In other cases, it'll be hitting a document DB. The point is that it's basically saying, here's how you go get the information you want in order to solve this problem, as opposed to going and trying to solve the problem. And it decouples it, right? It takes it away from the AI, the necessary to give it all the information. It's also more performant. Right, we're able to get much better performance time on it. In many cases, you end up caching the result there because you're going to be doing the same thing for multiple consumers. And it gives you also a lot more confidence that you aren't, A, doing hallucinations, right? But B, that you aren't really breaking any of the safety practices or the presentation practice. Like I have compliance obligations, right? And if it's really saying, if the AI is really picking from a bunch of predetermined compliant modules, right, then I don't have to worry about it introducing a compliance violation, right? And so it sort of breaks up a bit. So that's been one way we've applied it. We actually do that live today in our app and on our website. It works great. It provides a really good capability to the consumer. But I also think it's not identical to what people expect out of AI. People expect it to be sort of an all-knowing oracle, right? You give it everything, right, and it's going to give you the best possible answer on that information. No, there are other ways we can use it to get a great outcome for the consumer that also is more affordable for us to operate.
I think it's a very, very good way of doing it. It's not only affordable, yes, and you avoid the problem of having a hallucination. Although I don't like this word so much because I think hallucinations are the biggest feature of LLMs. Actually, we should cherish that feature. We can talk about this, but you have a deterministic result, and you can combine a deductive graph of a human with a inductive reasoning capabilities of this AI in a very, very meaningful way. Right? It's not only a price thing; it's also a very meaningful way of hybrid, right? Combining these two together. Are you mostly using outside like APIs to access, or do you install these LLMs or SLMs locally?
It's mostly outside APIs. I think there are places where it would make sense to do it differently, and certainly where there's experimentation. But for speed to market, it makes a lot more sense to use outside APIs, and we're pretty focused on speed to market. And in some cases, the biggest challenge in getting AI features to market is really the infrastructure. It's less about the model, right? Like the model isn't sort of like, I'm not being like, oh, this model is 5% better than this model. It's like, actually, how do I get it so that the data that I actually want to be used is where it needs to be in order to use it at a speed and price I want to use it, right? To get good enough. And that's all infrastructure, right? We just have completed a very large AI project around financial service product recommendation. We have a ton of data and we have a ton of financial service products in our marketplace. And we wanted a hybrid approach where we use both traditional data science and machine learning together with LLMs to get to really good product recommendation. Our problem there is that we see 40 million consumer credit applications a month. And, we have a database that is, at this point, hundreds of millions of users and leads and profiles, and and thousands of attributes. You cannot feed all of that into something to really get recommendations. So where was the effort? Well, there's going to be a lot of work on tuning the model, but the most important thing was actually the infrastructure to do clustering, right? So that we could actually do that in an efficient, high performant way, right? And make sure that we could actually iterate on the models in a quick way that was cost effective. So it wasn't the AI, it was actually the clustering infra and also getting the CDP infra right and the identity graph work. It was a bunch of very traditional stuff that had to be done before you even think about the AI portion of it.
I very much agree with you. As an engineer, I experience this all the time that that part is actually harder than the AI part.
The AI part's easy once you get the data there.
So you have talked about some of the use cases that you are doing, and you also mentioned before that you think that the product layer is going to go through a big revolution with AI. And there are people out there, I'm actually one of those, who thinks that any interaction with a machine will go through some kind of an AI layer. Almost doesn't matter what machine it is, right? Like it could be even your watch,
Sure.
right? And so how do you think about that? Because that then mostly at the edge.
I mean, what do we mean even when we say go through an AI layer, right? Like, here's my point is like you could have somebody who's using a mobile application, right? And that mobile application throws off 1,000 events, right? I could have all of those events piped into it, and they can then say, okay, I'm going to optimize your experience according to that in the future. That is an AI layer. Another is I could say that, okay, the actual UX itself is going to be some sort of AI interface in order to do outcomes. There's a bunch of different ways that we can say there's going to be some AI layer applied to it.
Definitely.
And so generally speaking, yes, but what that form factor is, it's probably all of the above, depending on where you are, but I don't necessarily have an exact picture of it.
Yeah, definitely. I agree with you that it's going to be very diverse, right? I mean, even if you think at the simplest things, you sit in an opera and you look at your watch and does the light turn on or not, is already a question that AI could probably do better than some rule-based system, right? And at the same time, as you said, I think that's going to be the real challenge, is going to be not only to have like a router that AI is doing at the end or at the beginning, deciding something, but also writing functions itself and and changing it and adding adding to the application ultimately.
One thing we did was we used AI to generate the rules for a rules engine. Because the rules engine was going to be the fastest and most efficient way to actually get to a given outcome, but we wanted some very complex rules on a large data set. So then we were like, okay, looking at this large historical data set, how do we get to the ideal rules? Well, we'll use AI to generate the rules, and the real system is just going to be a rule engine, right? Because looking at your watch probably doesn't require AI to figure out if the light should go on, right? That probably should just be a rule, right? But maybe you have AI generate what the rules are. Right, and you get to something a little bit faster that way.
Yeah. You're very right? But you could argue that if AI is generating this rule, it's yes, it is at that moment not learning anymore. That's true, but it has basically learned through this AI system. Right, ultimately. Yeah, I mean, I always come to this example because I have a home with what they call smart home. And I always experience it to be not very smart because all they have done is they put the switches on, from the wall to my phone, but that doesn't make it smart.
Yeah, the real automation that I've seen, and it kind of sucks, was Nest with basically determining if you're home and adjusting the temperature based on that. That's a little bit of automation, but not really that great. I've actually shied away from it for a while. I went deep on it, and then I eventually realized, like, actually, I know if I want the light on better than it. So a little bit.
Yeah, that's interesting. So you think that the skill sets that AI will require from engineers, but also in other roles, is going to change so dramatically that it's hard to find skilled people, or do you think it's just an exaggeration?
I think when it comes to the software engineering side of things, not so much, right? Certainly when it comes to data science, yes, right? I'm not a data scientist, so I probably can't speak on what the differences in those skill sets are. A lot, I think, of what engineers are doing with AI is a very powerful, but still not too disruptively meaningful change from what we've been doing for years with Code Complete or other, assistant tools in the development environment, right? Until you outright are replacing the engineers and actually having the AI write it, a lot of it is this optimization on 25% of the engineer's time initially. It's like, I can do code complete and code generation according to some ideas I had much faster and better than I used to be able to do with the template based stuff. And then I can probably get to my architecture and validate my architecture a little bit faster than I was previously, but I'm still going to go through a very similar process to do it, right? We're going to be operating like that in that sort of AI assisted mode for quite a while. But eventually, I think it'll probably make that jump to where actually you don't need to do that. I just don't think it's as fast as people currently think it is. I think the skills you need to do that are very, very similar to, just being a senior engineer and saying, okay, how do I come up with, defining the problem and the right architecture to do it? How do I break that up into a smaller set of components so I can solve it in a rational, maintainable way over time, and maybe distribute the work across other people who are going to do it? And in that case, other people might be AIs who are doing some of those smaller pieces. I do think the biggest threat of AI from a engineering jobs perspective is junior engineers, right? I think that in many ways, I view AI as a very effective, cost-effective junior engineer to augment my senior talent, and maybe I hire fewer juniors as a result of that. But in my mind, it also means I probably want more seniors because they're going to be so effective and have such a big impact, right? So that might have some interesting dynamics for the hiring landscape.
There are a few things I couldn't agree more with you. Like, for example, that it's very slow. I'm literally trying to do this new vibe coding, and I require now 3 computers because you prompt something here and then it takes like 2 minutes, but you're not going to watch it 2 minutes. So you go to the next computer and you're switching basic. So yes, there's a lot of waiting time, and it's somewhat weird because the same thing that takes now 2 minutes took hours just merely a couple of months ago, but that feels so far away. And now you're actually thinking, why does it take like 2 or 3 minutes, right? So that's at least my experience.
But you still have to have the understanding of going through and making sure it's what you want to work, right?
Yes.
The amount of time, the amount of mistakes I find, they're heavily
I agree
error
with you.
prone and very much go off of what you want. Like that's one of the things that amuses me about vibe coding is I actually think that you really do need an experienced engineer at the helm.
That's true. I actually very much agree with this. If you know engineering very well, then vibe coding is really very helpful because then you just understand where there is a strategic error and you just go and fix the strategic error. I 100% agree with you, and that makes it much faster. The one thing that I have a different experience is in the prompting.
Yeah.
So, for example, and I have done this experiment a lot lately. If you go to an AI system and tell this AI system, write me this code, and I specify it very well to the client and a server. They need to communicate with each other, and I want it to be compressed, and maybe you use Google Photobus for this, and so on and so on. Right? You specify everything, it does it, and it's usually good. But if you literally start with the sentence, I have no idea about engineering, I know nothing, I just have this problem, please help me, it oftentimes comes, and I'm not exaggerating, with a better solution that most engineers wouldn't have thought of. At least that was my experience, right? And that's only true for this latest generation of thinking models, like an O3 and Sonnets. But you're right that it will do lots of mistakes along the way. So you have to really watch it.
I've seen things like that, but I've also seen it go in a very dangerous way. I actually was trying to build something. I needed to build another relatively simple rule engine for reasons I was actually personally doing it. And I used AI to write it, and it would work according to my instructions, right? And then I looked at it and what it was doing, and it had introduced some of the biggest security vulnerabilities I could possibly, like, if I wanted to say, if I had added to the prompt, do this in a way that creates the most security vulnerable system you possibly could. This is what I would have expected to give me. And
Yeah, that's
it was definitely a novel solution, right? And it involved an awful lot of eval statements. And I was looking at this like, God, if somebody who doesn't know what they're doing asks for this and put into production, they have just like compromised their system so badly.
and I think that can happen, right? Because many people will code like this,
Yep.
and you will have lots of code out there. We just assume that it's all going to be perfect code, but that's definitely not the case.
I know it worked. It just, it was going to execute any arbitrary code you wanted to at the meantime.
Yeah, I mean that is actually a general problem of AI. I don't know if you have read the, and it's not even latest, but research from Anthropic where they showed, I think it was best of N jailbreaking, where they show that you can, even a highly instructed AI that has been instructed not to answer to specific questions and so on, like how to do the bomb, I don't know, these kind of questions, you can still convince it to do it even in an automated way. So it's almost questionable if we are actually able to, instruct it in such a way that it really only does what we want it to do.
I think that's the concern of many, many people. Like we may have unleashed something quite dangerous.
Yeah. Jeffrey Hinton the other day said, the problem is it is a very small, cute tiger, and you want to cuddle it, but you know that at some point it's going to be very big and not so sweet anymore, right?
Yeah.
There's a big trend of more and more memory in this they call context window in
Yep.
AI. The general idea is if you would have a unlimited context window, then the dynamics change entirely, because now you don't need to train a system anymore in a traditional way, but you could instruct it along the way. It was like almost learn socially like a human is learning. And maybe you have seen in a couple of weeks ago, the Meta released their latest series of Llama models, and they have already 10 million tokens, which is huge.
Yep.
Before that, Google was like the world champion, I think, with 2 million tokens.
Yep.
Do you see that trend, useful trend, and important for you?
It's definitely one of the things that we ran into with a lot of what we wanted to do was the constraints of the context window, right? And so we actually were leaning very hard with Gemini and Google for a while because of the context window. Over time, we realized that it was going to be a very long time before we could find one that could literally do everything, be large enough that would actually literally do everything we needed to do. And even if we did, it would be prohibitively expensive. And so we started architecting around that, right? And I think that it didn't introduce unacceptable trade-offs. There definitely were some trade-offs that we had as a result of trying to constrain ourselves a bit more. But there were workarounds. But I think that context window is, important for both those product applications, but also when I look at sort of just like enabling developers to use AI, right? Like the ideal thing is it should have my whole code base in it, right? It should know everything about my architecture. It should have all of my analytics from Datadog. It should have all of my deployment configuration and rules. All of that should be there. We wanted to have everything, right? And then once it has everything, then it can actually potentially act as an independent engineer, right? And so the drive to that is definitely important. And I think that's sort of like, when I look at a lot of the developer tools out there, like Cursor, right? Cursor is amazing, but it hasn't solved my big problem, which is like complete contextual awareness of the code base and how to actually get something live, right? There is nothing I can go buy that'll do that right now.
That's true. Right now, you definitely cannot do this. And I had this experience with Cursor. I actually really love Cursor.
That's
but
right.
I had this experience that I told it to write all tests instead of unit tests with this py testing, and it would like flip flop. Like it would go and write all the tests again in this py test framework, and then it would, with the next command, it would just delete all this and then write it again with. So you have, of course, these things that happen in the background. I think there needs to be a lot of tooling to understand what's actually happening.
That is my fundamental take. I think so much of the barrier is the tooling. I think a lot of people are focusing on what's the capability of the AI itself. And the reality is that we have a lot of pick and shovel work to do. And that's the case every time we have some new hype cycle and some new cool technology. Yes, there's a lot of promise in this tech. Now let's go solve the tooling and the picks and the shovels to actually make it applicable at scale for most institutions.
You touched upon something else, which I think is, very, very important. You said that it needs to have all these data and to be useful to me. Do you think that we'll see a new wave of data lakes, basically, but which are not anymore that unstructured as they used to be, but basically think of an AI system, and I wouldn't say LLM, but an AI system that is almost like a data lake.
What we want to do with AI, we are radically altering our approach to how we handle our data infra, right, across the organization. I think we've had a CDP in production for a while. It has had some deficits compared to where we want it to be. And as we're looking at the next version, a lot of it is questions about like, how do we make it sure that we have the control and audit history of the data to make sure we're using the right data at the right place with the model and that we get it there quickly and that we're able to have everything we want to be there basically in one place. It's a really, really hard problem, right? Especially our company, we are powering consumer experiences on thousands of other clients, right? We're a distributed marketplace as well as our own and operated properties. So I see consumer interactions from publishers, mobile applications, banks, the properties we own. And ultimately, we want to have a holistic understanding of the consumer. And we want to be able to use that holistic understanding to get outcomes from AI. But depending on where we got the data and when we got the data, we may have different permissions about how we can use that data. Right. And so a lot of what we care about now is about, how do we actually get our data into the place where we have a high degree of confidence that we are using verified permission data at the right place at the right time and that it is accessible to everybody who needs to use it. Accessible isn't just to the models, but it's to feature stores and data scientists who are doing work on creating like the things that feed into it. Right. That's a lot of complex infra, and that infra has become much, much more important to us as a result of AI. I think the other thing that's interesting about that is it's given us a lot more to think about when it comes to, how confident we have to be about data accuracy, right? And so, there are different use cases for data point where we may be okay with this being inaccurate because it's a marketing use case. But if it's an underwriting use case, then we have to have complete confidence in the data, right? And so how do we actually track our confidence and attributes across these different systems when there's a lot of aggregation and shoveling of data between systems? So that is actually, again, it's the infra that's the challenge. And that's really what we've been thinking about. And because of AI, it's even more important.
Yeah, more important, more challenging because of the sheer size of things. And
yeah, I mean, there's a lot of stuff that's making it more useful, like all this open table stuff, Iceberg, I think we're seeing a lot, we're getting great results on that. We're seeing other companies do the same thing. We also have a increased demand for portability of data, right? The idea of being locked into one data warehouse or one platform is unacceptable because things are moving so quickly, right? So on top of needing all of that accuracy, auditability of the data, we also want to make sure that it's extremely portable and that we don't have lock-in into one particular set of tools because it's going to change quickly.
Yeah, Iceberg is a very good way to go. So obviously, when we talk about AI, we mean LLMs mostly. And when we say LLMs, we mostly mean text-based things. But obviously, it can also now speak and listen and look at pictures and draw pictures. And I think that, how do you think about this? Does that open a new area?
Well,
also
for us, it's been awesome, right? Because like we in our consumer app, right, we focus really heavily on engagement, right? Like, most of the time when you think about a financial management app, it's like you're going in and your first thing you're going to see is your balance or your credit limit or something like that. If you log into MoneyLion, the first thing you're going to see is a TikTok-like content feed right, of highly engaging content, some of it entertainment, some of it educational, all of it oriented around finances or lifestyle or things that matter, right? And so we are pumping out content into that feed, right, to sort of drive engagement and education. And we need to produce content at scale, right? And we also need that content to be produced at scale in a way that's compliant because we're talking about people's money and like, you can't say certain things and other things you shouldn't say and other things you just don't want to be wrong on. So again, a lot of it came down to, okay, how do we have the tooling we need to use AI to generate content at scale that we are confident is safe to put out there, right? But it's opened up a whole lot of things. Like we are taking long format financial research, right? Like think about investor research that these companies produce, 60-page documents that are dense and unapproachable to most people. Well, we can use AI to turn that into 1,000 pieces of TikTok-like content, right? That can drive engagement and can help people like understand their finances or think about their finances differently. And so, that is the kind of place where the AI tooling is just absolutely fantastic. We've been able to do video where, record an actor once and have them do 10 different things, right? Like we're actually doing that in our content feeds and production at scale.
Wonderful. Well, you're really fast in putting this into products.
That's sort of always been MoneyLion's thing. We often move very fast. Sometimes we don't stop to think first, but that's sort of how we operate. It's actually all out there, and it's been there for a while. Like what we've been doing with content, this isn't something in the last 3 months. We've been doing this for, at this point, years. And we've been applying a lot of AI techniques to some of the financial evaluation we do when it comes to our earned wage access product for years. It's very, very hard, right, to do a small dollar earned wage access product, right, without a high level of automation, because you're talking about giving somebody $250, $300 for a couple of days, right, and you're not charging them interest, right? It's a crazy product. There's no interest. There's no credit recourse, right? You can't hit their credit report. You can't go after their paycheck. So you have to be very good at actually making the decision, and you have to do it very quickly and cost effectively.
Are you operating in the United States or also outside of it, like in Europe and in other places?
Almost all of our business in the US. We do actually operate a little bit elsewhere, but that's mostly so our employees can use the app, right? We're a US focused company. MoneyLion is sort of a PFM neobank, exclusively focused on the US. Engine is our enterprise business. Engine powers financial service marketplaces and personal financial management apps all over the US. If you make a list of the top 10 consumer fintechs, we are doing something to power them in some capacity. And so we're very much sort of like the APIs behind the scenes for their marketplace capabilities. And that's always been a very data science driven function because, our job has been to figure out what of the financial service products that they don't offer that we can bring are appropriate for a consumer. And how do we do that really, sub-second, really sub 200 milliseconds. And it's very high volume. Like I said, it's in excess of 35, 40 million credit applications a month, right? You can think about how many consumers and impressions. It's just a massive fire hose of people and data who we're constantly sort of scoring, reviewing, and making recommendations on.
I think regulation is not a big topic in the US, but I know that you care. I mean, compared to Europe, sorry, I understand that you might feel a bit different, but in Europe, we are a little bit...
It depends on what you're doing. I'd say if you're saying AI regulation might not be a big topic in the US, sure. But, you have to remember about financial services.
No, I meant AI.
Yeah, but that matters because when you're applying AI to things like credit, right? It doesn't matter that you're using AI or not using AI. There's a level of accountability, auditability of what data you use and how you use it, right? That is heavily scrutinized. And in the US, that's potentially 51 different governments. So it's not like there's one state organization doing banking and credit and insurance in New York. There's probably one for each. And each state might have one, right? So when we talk about regulation in the US, maybe there's parts of the federal government that don't care about AI. But the application of AI to financial services is heavily scrutinized.
Thank you so much. But last question, I can't not ask you this question. Are you also doing this digital twin thing where you try to model your customer as a program simulated somewhere? That's something that
I'd have to ask my data science team. I honestly don't know. That
Yes.
sounds cool. They should be doing it. That sounds like very much the type of thing that my data science team would do. I think they probably are, because we are constantly simulating how changes to either underwriting or decisioning or recommendation, right? How the changes will affect the consumers. And we have enough consumers where we can get a pretty good simulation. We're constantly back testing. So I think what you're describing is a new version of back testing, right? And so I imagine that is something that we are exploring, but I can't say definitively.
Thank you so much, Phill. This was very, very interesting, very refreshing. I think that a lot of engineers now listening, we're very happy to hear that, because mostly they hear that you'll be out of a job pretty soon. So
I don't think that's. I think it's going to be hard for some people, but I see it as AI assisted, right? And I think that it's going to make the best better. And I think, it was interesting. We had this whole period of time in software engineering where we had all the code academies, and it was really anybody can code. And I think that actually produced some pretty bad code and some pretty bad software engineers.
Oh, very bad. Yeah.
And I think AI is probably going to lead to a more disciplined, mature profile of software developer going forward. I don't think they're going anywhere. I think that I don't even think they will be paid less necessarily. They might be paid more because the amount of impact they can have is even bigger. But I think it's gonna be a focus on the best, right? And that is gonna be a transition.
Phill, thank you so much.
Thank you very much for having me.
Wish you continuing success on your journey. Thank you.
Thanks so much. Appreciate the time.